We have completed the pre-layout simulation and we are going to design layout, and after the completion of layout design I am going to check the results of layout design and comparison of both pre-layout and post-layout simulation results. Select schematic and go to launch layout Excel. Okay. View and type must be layout. Select OK and a window is open here. For fit, use F. Go to connectivity, generate all from the source. Use chaining option to decrease some of the connections. Minimum separation as 0.12. I'm taking all the transistors and ports in boundary. Take metal pinches. Take pinches metal one and apply. Generate. OK. Use Shift F to see drain and sources. Use S to increase the size of the boundaries. Was fit. First go to window, assistance, navigator. Navigator tells the connections of poly to poly or anything. First I am creating substrates for PMOS and NMOS. To create substrate, select the transistor, press Q and go to parameter. Body type must be detached. Select top tab and from another PMOS same, go to detach, top tab. OK. For NMOS, select press Q and body type detach and bottom tab. Q, body type detach, bottom tab. I'm increasing first I'm commenting VDD connections. VDD. Here we want to connect this transistor and substrate and this transistor and substrate. Afterwards we want to connect the pin to this substrate. So take metal pin, press P to get the path. And connect this pin to substrate. See here VDD connection is completed and we get a wire symbol. After then VSS. VSS select VSS and press path. This must be connected to the substrate. And now this pin is connected to substrate. The VSS connection also completed. I'm next going to connect A. B. To join poly, we need poly plus path. And if we take the connection like this, there will be an error. So I'm taking more cross. Press enter. Yeah. So we cannot join poly with the metal pin. So we need wire. To get a wire, press O and place the wire here. Take the path. I'm taking a line. So use A to align any two components. Now the port A connection is completed and we are going to connect port B. We want to join these two polys. So take the layer as poly. We cannot join the metal pin to this poly layer. So we need wire. I'm taking the wire here. Connecting the poly. For alignment, press A. So this connection is path. Select metal 1. The port B connection is also completed and output port is remaining. We need to connect these two metals using metal. Select path. Again, I'm taking the connection from here. Poly overlap will cause a design rule check error. So poly should not be overlap. A metal and a poly overlap does not cause any errors. Overlap of metal and metal also cause error. To join, press enter. All the connections are completed. So go to Ashura and technology. First we need to add in technology. Press on these two dots. On the technology Ashura tech.lib. Select OK. And again go to Ashura, run DRC. Here select the technology GPDK90 and select OK. No DRC errors are found. Now go to Ashura, run LVS, add technology GPDK90. Select OK. Yes. Here see schematic and layout are match. So NS. Another window will also open layout versus schematic. Layout and schematic are match. Now go to layout design, Asura, and run RCX. Go to extraction. Here the output need to be in extracted view. After that go to extraction. Extraction type is RC and reference node as VSS. Go to filtering. Here enter power nets as VDD factorial and VSS factorial and ground nets as VSS. Need not to change any connections. Select OK. The Shura RCX run completed. The output is in. To the completion of the RCX run. Now go to Virtuoso window. Select tools. Library manager. Here select NAND gate test bench and open another file. Here the cell type is config and select OK. A new configuration window is opened here. Keep the view as schematic and press use template, and here the name as Spectre and select OK. OK. Here save and open and do the simulation here. First analysis. I'm just taking transient analysis only. The stop time is 200 nanoseconds. Here accuracy defaults as moderate. Press OK. After that go to outputs. Select from schematic. First select input and after output and run the simulation. Here these are in previous simulation video. Now go to config window and now select on schematic, give a right click, set cell view and press AV extracted. Afterwards save and again open. When we open again there will be previous ADL window. So here in plotting mode just keep append in place of replace and run the simulation again. Now split and we have seen two inputs. So drag this input into this and B input this and output into this. So I am changing names. This is A underscore schematic as SCH. This is A underscore layout for layout. ISCH schematic. To see the parasitic difference, I'm zooming in. Let's see, I'm changing the color of this Y layout. Red color. See, this is the parasitic difference between the post layout and pre layout simulation. These are pre layout simulation results and these are post layout simulation results.